we didn't see the actual microprocessor when working the other day. We had, like, here's a Core i7. It has a shiny thing on top. Did we see that when you took apart the computer? No, you'd never see that. What's on top of that?
Thermal paste.
Thermal paste and then a
Pizza.
cooler.
Oh.
There's a piece of aluminum something or another. So this is just showing that's a microcontroller. Okay, I don't want a microcontroller. Let me do let's do CPU parts, maybe. Okay, that's not a CPU. That's not the part. CPU diagram. There we go. So a CPU, let's see if I can make this bigger. Image in a new tab. Okay, that'll work. So inside your CPU, this is kind of the basics of how it works. So think of this as your brain. The CPU has to have some place for things to come in, some place for things to go out, right? Makes sense so far. So there it is. So we have information coming into the CPU from RAM. This is our little RAM stick. And then over here, it's a very poor drawing, but this is our hard drive where we store things on long term. So the CPU we'll just say, even though there's multiple cores for the sake of this discussion, we'll say that this can only handle one thing at a time. So it does one calculation, it sends it to the output. Well, where do you suppose its output is? It goes into RAM. And then it could be stored on a hard drive. The output could go somewhere else. But the first thing it does is it goes to RAM, random access memory. So the input and output is some sort of memory, some sort of temporary memory. The CPU does not talk directly to hard drives or anything else. It sends it to memory, and then that gets, run by something else. Let's just look at this piece. So we bring in our input. Well, there's a concept called caching, which just means that here is where I'm doing my thinking. I can only think about one thing at a time. When I'm done thinking about that, if I have to go all the way out here to the hard drive, and then here's my next thing I need to think about, I have to bring it all the way back, that's going to be very, very slow. So what we have is layers of information in between. So we have something called an L1, L2, L3 cache. It says primary memory. I'm just going to call this a cache. Difference between cache and memory, there isn't any. It's the purpose. So if I'm working on something and I know I'm going to need it right away again, I store it very close in very fast memory, which is called I think it's the L3 cache, which is the closest one. But it's expensive to have very, very fast memory, so it's not very big. Well, I'm not going to need it for a little bit longer, so then I shuffle it out here where it's a little bit slower and there's a little bit more room. But it's still way, way faster than regular memory. And this is all on the chip itself. And there's actually another one. There's 3 of them. And this is slower and bigger, but it's still way faster than your RAM, which is way faster than your drive. So as I'm working on this stuff, think of it maybe like an assembly line. Stuff is coming by, I'm thinking about it, it gets put back on the assembly line. I don't need to work with it anymore. It gets washed out to here, gets washed out to here, gets washed out to here, and then eventually I save it. The further away we get, the slower it is. If I'm working on something like a Microsoft Word document, it might all be stored right here and I'm done. And then eventually as I'm done with it, it'll get stored in memory. And then when I do Control S, it gets saved here. So much of what we work in IT has your primary piece, and then there'll be little places of storage that are closer and faster. And then there'll be long-term pieces. So at the CPU, we have 3 places to store things where we can get to them very quickly. But they're more expensive than RAM. And so there's an algorithm that the CPU uses to determine, well, I'm done with this. Let's flush it clear out to RAM. And when you do Control S, it saves it to the hard drive. So hard drives have cache. Memory has cache. Your browser has a cache. So your web browser has a disk cache on the computer, because if you were just at google.com and went right back to there immediately, If it hasn't changed, it gets pulled from the hard drive, which is faster than going out to the internet, past 40 routers and back again. So there's caches of stuff everywhere. And what it does is it keeps the things that you've used recently closer to where you are so that you can use it more effectively. So if I have a cache of pencils up here, I can get to those pretty quickly. But if I have pens over by Shauna, I have to get up, walk over to Shauna, pick them up, bring them back. So that's like I'd be putting them in memory. And if I wanted to put it in the hard drive, I got to go clear back to William back there. But if it's all on my desk, I can go, I'm really fast. So a lot of our hardware works just like that. We have temporary storage that's really fast and close to whatever is doing the thinking, the CPU. We have a little bit slower storage that's still temporary. We have long-term storage. Every device we have in this room that has half a brain has these same functions and the same stuff. Same idea. This has cache, it has processor, it has, well, now CPUs have lots more cores. Every CPU core has 2 arithmetic logic units. So a CPU core can actually do 2 things at a time. So if you have an 8-core machine, you can do 16 things. Let me turn this off. And let's, if you want to, right-click on your taskbar on your computer. We're going to go to Task Manager and take a look at that. And whether you want to or not, it'd be a good idea to do it. So Task Manager allows us to look at a lot of things. If you're not seeing this big thing, I don't remember where the button is. There's a button you can click to say Show Advanced View.
Very left on that little list. Second thing. Yes.
Oh, I meant the thing that makes it look, when the first time you run this, there's like nothing showing.
Oh.
I don't remember what that is. Anyway, if there's nothing showing, I think it says switch to advanced view or something. There we go. Anyway, eventually mine's really big, but this is a window like anything else. You can make it smaller and drag it around. And if you don't know how to make things smaller and drag them around, or you do a YouTube video to help you do that. So yes, you're right. This is where we want to go, Nathaniel. This shows us our CPU utilization. This shows us how much memory is being used. I'm using half my memory and I'm not even doing anything. Oof.
That's Windows.
Excuse me?
That's what Windows is doing.
Yeah, Windows 11 is a hog. What we're wanting to look at is down here. We have 6, so we have 1 physical CPU. We have 6 cores, and it says we have, and I keep forgetting to look this up, we have 12 logical processors, but I think inside of each logical processors, we have 2 ALUs, arithmetic logic units. So I think that means we can do 24 simultaneous things at the time, and I always forget to look that up. Well, we can do 24 things at a time, or just say we can do 12 things at once, simultaneously. If we go to this one, look at all these things that are running on your computer. These are all processes, meaning like Google Chrome is not a single program. Look at all that stuff. It's running all these things. It's not a single program. It's like a bunch of programs at once. So are there only 12 things here? No. So what and how in the world does the computer run all these things at once? You might know. Nat, you know, Nathaniel? How can the computer run all these things at the same time when we only have 12 cores?
Different caches and all the different memories.
Yeah, but how can it keep track and run all these programs and processes? Yeah, in Asio.
Using base speed,
Doing what?
using base speed.
Okay, that's a good thought. It uses something called time slicing. Everybody takes their turn. The operating system says, well, you've had my attention for, 0.001 microseconds. It's time to let Task Manager have his turn. Oh, you're done. Let's go to VirtualBox Manager. Let's go here. Let's go here. Let's go here. Let's go here. So since Unix came out, And Windows and anything that uses a processor, it uses what's called time slicing to distribute the task. So that means Shauna will do something, Alex will do something, and then somebody else will do something, then it'll come back to Shauna. The operating system controls that. It determines the priority and who is doing something at one time. You don't see it task switching, but it is all the time. It's task switching. It can do 12 simultaneous things, but everything else is task switching. Like with a computer in your head, you can do one thing at a time. Anytime you think you're multitasking, you're not. You're task switching. You're going from one thing to the next. That's lots of research on that. So you think you can listen to your phone and text people and all this stuff. All you're doing is interrupting your thought process and taking longer to get back to whatever it is you're doing. As a sports person, sports people probably know what in the zone means, or when you're not thinking about anything else except what you're doing. When you're working on something important, like a homework, should be the same thing. All you should have in your brain is that. So in the middle of a basketball scrimmage, you see a lot of players going, just a second, oh, I got a text coming in. Do you do that when you're studying? Oh, there's a text from my friend. That interrupted your studying, right? So a good recommendation is to, when you have a place, make a place to do your homework. Shut the door. Turn off your phone. You can live without it for an hour. I can live without it for a long time myself. I didn't grow up in the having to be attached to a phone age either. So I think I was fortunate in that respect. But make a place that's all you do. Get in that zone for a certain amount of time. You'll get a lot more work done. You think you can do multiple things at a time, but you can't. Our brain is not designed that way. All right. Yes, Ignacio?
I have a question to ask. I've noticed a trend like with the computers and even yours, like